my name is Susan Copeland and I'm one of the 6 elementary math curriculum specialists for CMS. Today we will be taking a deep dive into Unit 5, Place Value Patterns and Decimal Operations. As you dive deep into Unit 5 today, remember our goal is to support students to know mathematics deeply, to apply mathematics, and to enjoy mathematics. After watching this video, you will understand that 5th grade students should describe the value of digits as 10 times greater for each place value left the digit is moved, and 1/10 the value for each place right the digit is moved. Students may describe the digit moving right as either 1/10 the value or as divided by 10. You will also understand that students need to be able to represent numbers from the thousandths to 1 million using standard, base 10 form, number names or word form, and expanded form, including with fractions and decimals, and understand that 5th grade students add, subtract, multiply, and divide decimals using models and place value strategies. Okay, so let's get started. Here's our agenda for today. We will work through these sections today. On each title page, you will see the parts of the agenda through which we will be working. Underneath the title, you will see the tasks that we will address in that section. Let's get started by accessing some important documents. First, you will also need to log into My NC Ed Cloud and access MathRocks. The enroll code is on the screen if you need to enroll. Once you are in MathRocks, select 5th grade. On the 5th grade page, you can access the year at a glance using the top right button. Then select Unit 5. Unit 5 actually begins at the end of Quarter 2, but you will find it on the Quarter 3-4 tab because it's mostly in Quarter 3. Everything is in a folder in the Unit 5 link except the curriculum guide. I will refer to the curriculum guide throughout this deep dive, so you may want to have it open. You will also need to access the note catcher using the bit.ly on the screen. Pause if you need to access these resources. Our first section is the unit overview on your note catcher. In this part of our deep dive, we will familiarize ourselves with the overarching story of the unit. We always want to begin a new unit by looking at the North Carolina Standard Course of Study aligned to the unit. The standards are located on slide 4 of the curriculum guide. NC 5 NBT 1, NC 5 NBT 3, and NC 5 NBT 7. To get to the unpacking document, click on the Post-it note on slide 3 of the curriculum guide or on the unpacking symbol at the bottom of the MathRocks 5th grade page. Pause the video and take a moment to read and annotate or take notes about these standards using the unpacking document from pages 10 to 13 and 17 to 22. I'm going to share a few things I noticed and would want to take note of before teaching this unit. You might have some other things you noticed. That's the great thing about working with the team. We all notice different things, and if we share what we're thinking about, it gives everyone a stronger picture of the goals for the work that we want to do for Unit 5. Let's start with NC 5 NBT 1. Students describe relationships between digits to both the left and right of a given number. To the left, the same digit would be 10 times greater. To the right, it is 1/10 the value. Moving left, we multiply by 10. Moving right, we either divide by 10 or multiply by 1/10. Sometimes a 5th grader will say 10 times less to describe the relationship to places to the right. This phrase is actually inaccurate. 10 times would mean multiply by 10, not divide by 10. It is mathematically accurate to say 1/10 of times 1/10 or divided by 10. Move students toward that language if they begin using the more informal language at first. I also noticed that students can compare 3 places to the left, that is times 10 times 100 or times 1000, but only two places to the right, divided by 10 or divided by 100. Or we could think of that as times 1/10 or times 100th. We might also notice that 5th graders work with digits from thousandths to 1 million. And for NC 5 NBT 3, it's pretty straightforward. Numbers to the thousandths, standard form number names, which is word form, and expanded form. Expanded form is the most interesting piece to me. In these two paragraphs, we can see that expanded form may appear many different ways. This standard also includes comparing decimals using less than, equal to, and greater than symbols. And last, but definitely not least, is NC 5 NBT 7. This standard is packed. Within the standard, students add, subtract, multiply, divide, and estimate decimals. Within each operation, there are clearly defined number parameters for the standard. Students add and subtract decimals to the thousandths place, and numbers can include up to 6 digits. Students multiply with products to the thousandths and can include up to a 2-digit by 3-digit number. Students can divide a whole number by a decimal or a decimal by a whole number. Notice that students do not divide a decimal by a decimal. Dividends will have no more than 4 digits and divisors will have no more than 2 digits. Division is limited to the hundredths place. Notice that all operations call for the use of models, drawings, and strategies based on place value. Students should have access to decimal grids, but also have experiences creating their own on graph paper. When estimating, the focus is on reasonableness rather than simply following rounding rules. Let's move to summarizing the unit on your note catcher. This is located at the beginning of the lesson notes in the curriculum guide. Read the unit overview on slides 9 and 10 of your curriculum guide. When you finish, try to summarize the gist of the unit in a sentence. Then discuss with your team how the unit follows the design elements of invitation, deep study, and consolidation. Pause the video to complete this task. In this unit, students expand their knowledge of decimals to read, write, and compare. In this unit, students expand their knowledge of decimals to read, write, compare, and round decimals to the thousandths. They also extend their understanding of place value and numbers in base 10 by performing operations on decimals to the thousandths. Students use diagrams and their understanding of fractions to make sense of decimals to the thousandths. Diagrams help students to visualize the magnitude of each decimal place and compare decimals. Students then apply their understanding of decimal and whole number operations to add, subtract, multiply, and divide decimals to the hundredths using strategies based on place value and the properties of operations. They see that reasoning strategies and algorithms they use to operate on whole numbers are also applicable to decimals. Now let's think more specifically about how standards and targets build across the sections in the unit. This unit is separated into 4 sections. Read the section overviews on slides 12 through 15 of the curriculum guide. Then look at the 8 task cards from the unit on slides 5 through 12. Slide each task to be below the section within which it falls. Talk in your PLC about how you decided which section each task belongs with. How does each task support the goals of the section? Pause the video now and return after completing this sort. Here are the sections with the aligned cards. Cards E and C are cooldowns in Section A. This section focuses on writing decimals in standard, number name, and expanded forms. Students also compare and round decimals in this section. Cards H and B are cooldowns from Section B. These cards address adding and subtracting decimals to the thousandths. Students should use models as they develop an understanding of addition and subtraction of decimals. Students may also use place value strategies to add and subtract multi-digit decimals. Cards A and G are cool downs from Section C. This section focuses on multiplying decimals using models. Students multiply a whole number times a decimal and a decimal times decimals in this section. Cards D and F are from Section D. Students use models to divide a decimal by a whole number and a whole number by a decimal. Students are expected to use reasoning alongside models for larger numbers. Let's do a little math now. Read the learning goals for each section. Try these tasks. How do these tasks support students with understanding the goals of each section? What strategies might your students use? Pause the video and continue after you've tried these tasks. Again, I'm going to share a few thoughts I had, but take them with the thoughts your team had as you worked. These are not the right answer, it's just some things I thought about. Before we begin this section, I just want to highlight that students represented decimals to tenths and hundredths in 4th grade, but 5th grade is the first time that students experience addition, subtraction, multiplication, or division with decimals. All the work in 5th grade with decimal operations should use models and strategies based on place value. The Section A task focuses on representing decimals using decimal grid models, fractions, and decimals. Students need to understand that 1/10 is one of 10 equal parts to make a whole, 1/100th is one of 100 equal parts to make the whole, and 1/1000th is one of 1,000 equal parts to make the whole. Whether we are looking at the model, the fraction, or the decimal, we say the name the exact same way. The Section B task was selected because I wanted to talk about the use of the algorithm for addition and subtraction in this section. 5th grade students are not required to master the U.S. standard algorithm for addition and subtraction with decimals. However, a through line in this unit is the relationship of operations with whole numbers and decimals. Students learn to use the U.S. standard algorithm for addition and subtraction in 4th grade. So many students opt to use the algorithm even though it's not required. For that reason, I left many of the places that suggest that students use the algorithm, but changed the directions to use any strategy rather than to use the U.S. standard algorithm specifically. That being said, I want to share a few thoughts about this task. First, the reason I like this is because it highlights a frequent misconception for students who attempt to use the algorithm for addition and subtraction, and builds on something very important to always remember when adding and subtracting any kind of number. That whole numbers, that is, for whole numbers, fractions, or decimals. We need to be very careful to add like units. Just like we add ones to ones and tens to tens and hundreds to hundreds, we also add tenths to tenths and hundredths to hundredths and thousandths to thousandths. What is important is that we add like place values, grouping for the next place value when needed. That phrase that most of us heard through school, line up the decimals, is really about making sure we add like places. The second thing I want to say is that if you have students who are not yet using the algorithm, students might attempt this problem another way. So how might they do this problem? First, you might ask students to solve the problem their own way, and then see which student they agree with for the sum and explain why. So what might students do if they do not use the algorithm? Of course, we don't want them to draw 693 holes or need 693 flat base 10 blocks. So what would they do? Students might use partial sums, adding one place at a time, like in this example. Other students may use the algorithm for the whole number part and decimal grids or graph paper for the decimal part, and then put those two parts together. The Section C task focuses on the meaning of multiplication as it applies to decimals. In problem 1A, students view this as two groups of 3/10. If students shade two groups of 3/10 on one grid or two, it is easy to see that the total is 6/10. For problem 1B, students view this as 2/10 of 3/10. That means for each of the 3/10, we must partition each of those tenths into tenths and then select two of those. When a tenth is partitioned into 10 equal parts, the new parts become hundredths. So 2/10 from each of the 3/10 would be 6/100ths. Problem 2 addresses a common misconception. Both factors are tenths. So why is the product not tenths? When finding tenths of tenths, tenths are partitioned into 10 equal parts. If all 10 tenths are partitioned into 10 equal parts, that makes 100 parts. So 2/10 of 4/10 would be 8/100ths. The Section D task is an interesting one because students are given one whole. But the problem is about 12 wholes. Students may feel stuck in Part A, but Part B shows a strategy that a student used to solve the problem. Finding how many groups of 2/10 are in one whole, and then multiplying that by 12. Now we're ready for backwards planning. Looking closely at the end of unit assessment before teaching each unit will deepen your understanding of what students need to know and be able to do by the end of the unit. Assessment resources are located on slide 6 of the curriculum guide. You can access the assessment by clicking on the assessment icon. If you haven't already taken the assessment, take a moment to complete the items. Consider to which sections each task is aligned and record the section on your note catcher. As you work, consider what misconceptions and challenges can you anticipate. When you finish, share your thoughts with your PLC. This is a great time to learn from the experience of your team. Here's a quick look at what I landed on. Section A is about place value, comparing and rounding decimals. Section B is about addition and subtraction. Section C is about multiplying, and Section D is about division. Let's think through part of a lesson together. Let's take a closer look at Unit 5, Lesson 23. In this lesson, students use estimation, whole number multiplication, place value understanding, and the associative property of multiplication to multiply decimals. In Activity 1, students explain or show why each pair of equivalent expressions is equivalent. In this activity, they are provided with the equivalent expressions. Take a moment and think about how you would explain it. In this activity, ask students to explain how we know the first two expressions are equivalent. In the activity synthesis, ask students to explain how we know that the first two expressions are equivalent. Look for students to notice that 7 2/10 is equivalent to 72 times 1/10, and 5 3/10 is equal to 53 times 1/10. Just like we were talking about earlier, when you take one whole and you partition it into tenths, and you find 1/10 of a tenth, you end up with hundredths. So this last expression that you see is just saying that when you multiply a tenth times a tenth, you end up with a hundredth. So when we multiply the two whole numbers, 72 times 53, we would just need to multiply that times 100 to get the product for 7 2/10 times 5 3/10. Let's wrap up our time today with some key points and next steps. Just as a reminder, 5th grade students should describe the value of digits as 10 times greater for each place left the digit is moved, and 1/10 the value for each place right the digit is moved. Students can also describe the digit moving right as dividing by 10. Students also need to understand and be able to represent numbers from thousandths to 1 million using standard or base 10 form, same thing, number names or word form, and expanded form. Expanded form may be written in several different ways. Take a look back at the unpacking document if you need to familiarize yourself with those ways. Fifth grade students will also need to be able to add, subtract, multiply, and divide decimals using models and place value strategies. So what are your next steps? Practice using base 10 blocks, decimal grids, graph paper, and drawings to represent, add, subtract, multiply, and divide decimals with your PLC. Most of us grew up just using algorithms, and so we're not always familiar with all of those different strategies, so it's really helpful in PLCs to use some of those strategies or to practice those strategies together so they're familiar before you begin teaching. And also, each time you plan, please use the resources in the Unit 5 curriculum guide. Those lesson notes let you know lots of things, including if a CMS lesson, like in this case we're seeing that lesson 1 is the illustrative mathematics lesson 1, but you will get to a point in this unit, I think at about lesson 17, where the numbers are off. So you want to make sure you always look at that so you know which lesson to tell students to turn to in their book. And on the lesson plans, the workbook pages are also listed there that students will need. Thank you for attending this virtual course. Please email any questions to me, Susan Copeland, at the email on the screen, which is also linked on the 5th grade Math Rocks page if you want to access that when you're not in this course. And we're also asking that if you find mistakes, if you have comments, thoughts about something that would be helpful, please add that to the feedback form, which is also linked at the bottom of the Math Rocks 5th grade page. Thank you, and I'll see you in Unit 6.